In this video, I'm going to give you some hints for problem 230 from chapter 12, which is a homework problem. A man can swim at 4 feet per second in still water. And he wishes to cross the 40-foot wide river to point B, 30 feet downstream. If the river flows with a velocity of 2 feet per second, determine the speed of the man and the time needed to make the crossing. Note, while in the water, he must not direct himself towards point B to reach this point because the current's going to carry him this way, so he wants to aim somewhere to the left of point B to account for the fact that the current's going to carry him as he swims. So the 4 feet per second, we saw something like this in one of the example problems that I did in lecture. So the 4 feet per second is not the speed of the man, because even if the man wasn't swimming, he would still be carried with the current downstream. So the 4 feet per second is the speed of the man with respect to the river. Well, we should say the magnitude because we're not going to figure out quite yet what direction he's going in. Okay, and the velocity of the river is 2 feet per second. Well, that's in, let's call it the I-hat direction, although I don't really think we need to use a coordinate system to figure this out. So let's define our coordinate system if we are going to use it. There we go. Okay, now I know other things too because they give me some lengths here. So it's 40 feet from one side to the other, and he's aiming for point B, which is 30 feet away. Doing a little bit of trigonometry here, you can figure out that this distance, which is the distance that he's going to be swimming, is 50 feet. This is going to be useful for us to look at, but before we do that, let's use equation 1234 to make a vector diagram for the velocities. If I have the velocity of the man with respect to the river, it's going to be the last term in my equation here, and I would add that to the velocity of the river in order to get the velocity of the man. Now I want to draw a vector diagram. I know the velocity of the river is pointing this way, and it's 2 feet per second. I have to add to that the velocity of the man with respect to the river, which has a magnitude of 4, but I'm going to figure out the direction in just a minute. And then the velocity of the man, well, the man, if you're standing on the shore, you see the man go from here to here, so that is the direction for the velocity of the man. So that would be going along this line here, so whatever this angle is, that would be the same as the angle that I have for the velocity of the man. And that's supposed to be the resultant vector, so I'm going to draw it like this. So this is the velocity of the man. So if I have to add the velocity of the river to the 2 feet per second to get the velocity of the man, then that vector for the velocity of the man with respect to the river is added to the vector for the velocity of the river. That gives me the velocity of the man. This is not supposed to be a right angle here. Hopefully you can see that. This angle here would be the same as this angle here. And we know the magnitude of this is 4 feet per second. So this side has a length of 4 and this side has a length of 2. If I have the lengths of two sides, and if I know one of the angles, then I can use the law of sines to figure out whatever else I want to know about that triangle. So my goal would be then to find one of the angles for my triangle here. Fortunately, because this angle here is the same as this angle here, and actually this angle would be the same as this angle, I can find the angles using what I have here and then use them for the velocity vector diagram here to find what I want to know. Well, I expect you to do it on your own, but I'll tell you what you should get. So this angle here should be 36.87 degrees. You know the lengths for all the sides of the triangle, so you can use either sine, cosine, tangent, whatever you want to find the angles here. This one should be 53.13 degrees, which means this angle here is also 53.13 degrees. This angle here I know, but that doesn't really help a lot at this point because I would need this interior angle, which is not the same. But you know the lengths of these two sides, and you know this angle, so you could now use the law of sines, which you can find in the appendix of the textbook, to find, what are we looking for? Determine the speed of the man and the time needed to make the crossing. Oh, you can use this to find the speed of the man. That would just be the length of this vector from here to here. And for the time needed to make the crossing, he's going 50 feet. When you find the magnitude of this vector, that's going to be equal to 50 feet divided by the time that he needs to make the crossing. So, there you go. So I may have been wrong about the law of sines being in the back of the textbook. I took a look for it and did not find it. But if you Google law of sines, you can just type in the information and it will tell you either what a side is or what an angle is. You are, however, going to have to use the law of sines twice, and along with that, you have to know that the interior angles of a triangle add up to 180 degrees.